Hello, sir.
Welcome to today's lesson in chemistry. I'll take you through. I'm Mr. Chivama. In today's lesson, we continue looking at the Moore concept. So, our lesson focus for today under the Moore concept, we are going to look at stoichiometry and percentage purity. So we are looking at stoichiometry and percentage purity. Stoichiometry and percentage purity. Now, before we go any further, I want to pose a question to you. So with me here, I have a boiled egg. Now, if I happen to give you this boiled egg, are you going to eat it the way it is, or you will first remove the shells?
First remove the shells.
Why are you removing the shells? Yes, hello? Why are you removing the shells from this boiled egg?
So that it can be easy to swallow.
So that it can be easily swallowed. Any answer? Yes, Dresma.
Because it is an impurity.
Because the shells are acting as impurities, right? So, same applies. So, for me to know the percentage purity of this boiled egg, what I'm supposed to do, the first thing, I'm supposed to weigh it the way it is together with the shells using an electronic beam balance. The mass that I'm going to get, that mass is termed as the mass for the sample, the total sample together with the impurities, or the sample for the impure substance. After removing the shells, again I weigh this boiled egg. The mass that I'm going to get, that is now the mass for the pure substance. Same applies in chemistry when we are dealing with what is known as stoichiometry. Don't be confused with the term, it is very simple. When we are looking at stoichiometry, which we've already looked at in our previous lessons, these are simply calculations that are based on equations, based on chemical equations. Are we together?
Yes.
Now, before we go, we have to look at what is percentage purity. By definition, what is percentage purity? Yes, Taylor.
Percentage purity is the ratio of pure substance to the pure substance multiplied by 100%.
So, according to Theo is telling us to say percentage purity is the ratio of the amount of the pure substance to the amount of the impure substance multiplied by 100%. So what does it mean? What it means is that if I am to find the percentage purity of any given substance, I should divide the amount of the pure substance to the amount of the impure substance, then I multiply it by 100%. So, what we've written here, so percentage purity is given by the formula percentage purity is equal to amount of pure substance. We divide everything by the amount of impure substance. Okay, let me say, we divide this by the amount of the total mass of the impure substance. Now, one thing that we should know is that it is very easy for us to determine the amount of the pure substance. Or when you are working problems based on stoichiometry, the amount of the impure substance is always given. What we are not given is the amount of the pure substance which we have to work out. After we've worked out, then we find the percentage purity and we multiply it by 100%. So now, if I'm to find the percentage purity of this egg, the first thing I'm supposed to do is to measure its mass. So I'm measuring its mass together with the shells, because we've said that the shells are acting as what? As the impurities, right? So when I measure the mass it is giving me, the egg together with the shells, before I remove the shells, that is what I'll call mass of impure substance. In this case, the mass that I'm getting here is 56.2 grams. What about the mass for the pure substance? So, for me to find the mass of the pure substance, I have to do what? To remove the shells. So, I am removing the shells from this egg, so that I wait and I find the new mass. So I'm removing the shells. So I'm trying to ensure that I remove those things I have termed to be impurities, because I can't eat the egg shells. What I want is the actual stuff which is inside. So I have finished removing the shells from the egg iron. So now what I have is a pure substance. So since what I want to determine is the percentage purity, I will reweigh my egg. Now this time around without what? The egg shells. Are we together?
Yes.
So I'm reweighing my egg. So after reweighing, without these I termed as impurities, the shells which I termed as impurities, I'm now having a new mass of, so now the mass that I have is the mass of the pure substance. And the mass it has given me is 48.6 grams. Are we together? Yes. So this mass is for the impure substance. For the egg which I had together with the shells. After I removed the shells, it has given me 48.6 grams. So for me now to determine the purity, the percentage purity of this A, I'm going to say, I'm getting back to my equation, which is amount of the pure substance, in this case, the mass. So what is the mass of the pure substance? So where there is the amount of pure substance, I am going to plug in this value. So let's work it out. So what are we saying? We are saying percentage purity. We are saying percentage purity is equal to mass of pure substance over mass of impure substance multiplied. We multiply this by, let me remove this line. We multiply everything here by 100%. Are we together there? So, where there is mass for the pure substance, we are going to plug in this value, which is 48.6 grams over 56.2 grams. We multiply this by 100%. So, 48.6. So now from your mathematics, what mass? You have to work out. We have to first divide, not so? Yes. That's when you can do what? The multiplication. So what is 48.6 divided by 56.2? Yes, Maxation.
86.5%.
86 point. No. Give us what you get when you divide. Yes.
We're going to divide 48.6 grams over 56.2 grams, and the answer is 0.864768683.
Yes, it is advised that before you round off, you show everything the way it was appearing on the calculator. Are we together?
Yes.
Yes. So that the one that will be looking at the problem you've worked out is able to tell to say, indeed, this number was like this. Now, on the next step, it has been rounded off. Are we together? Yeah, okay. So everything there, we are multiplying by 100%. So what is it giving you? Genesia.
You will multiply 86.476883 times 100.
8683%. Now, when you are working with the decimal places in percentage like this, it is advised that you leave it to one decimal point time. So this is the same as 86.5%. So this is the percentage purity. Then at the end, when you are done working out at the end there, you show what you were calculating for. So in this case, we were calculating for the percentage purity. So this is actually the percentage purity of the egg which we add. So meaning about 14.5% of this egg we add was made up of what? Impurities. Are we together?
Yes.
Okay. So now this is based on this egg. Now, questions do come. You might be given a question based on stoichiometry, where we are saying working out problems based on what? Chemical equations. So let's try to look at one question on what? On stoichiometry, on how we can find what? The percentage purity. Example 1. So, an impure 0.5.
Sir,
Yes, Caleb.
sir, I have a question.
Go ahead.
Can you calculate the percentage purity of fresh maize and what can you do to calculate percentage purity? Because fresh maize have 2 impure substances.
You measure together with the leaves. You remove the leaves. You measure. You remove the grains. You measure the stock together with the leaves. Because that thing, you don't want to use it. You can't eat that. We are together. An impure 0.5 grams sample of sodium chloride was added to a solution of silver nitrate. Silver nitrate and a white PPT, a white precipitate. And the white precipitate was formed. The white precipitate was formed with a mass of 1.15 grams. Calculate the percentage purity of sodium chloride. So now, this is a question now based on stoichiometry. So now, when a question is asked in this way, you want to find the percentage purity of sodium chloride. Mind you, as we are starting from there, they are saying an impure sample of sodium chloride. Meaning this sodium chloride adds some impurities. So in a chemical reaction, impurities will not react the way it was with an egg. The shells, we removed them because we said we can't eat the shells. What we want is the stuff which is found inside. So the impure part of the sodium chloride will not react. We want to find the percentage purity of sodium chloride in this mass, which is 0.5 grams. Now, when it comes to stoichiometry, you are working out problems based on chemical equations. If you want to find the percentage purity, what you must do is the first thing, you must formulate a balanced chemical equation. So in this case, we are told to say sodium chloride was added to a solution of silver nitrate. So this is a reaction between sodium chloride and silver nitrate. Are we together there? Yes. I think you came across this equation when you are looking at acid, bases, and salts under preparation of insoluble salts. So this type of a reaction, it is a precipitation type of a reaction. So we have the sodium chloride, which is in aqueous state, reacting with silver nitrate. So what will happen here is that there will be exchange of ions. The positive ions from this compound is going with the negative ions from that compound. Are we together? Then the positive ions will also go with the negative ions. So this will give us silver chloride, which is in solid state. So this is our white precipitate that will be formed, and sodium nitrate. Sodium nitrate, which is in aqueous state. After you've constructed a chemical equation, the next thing that you're supposed to do is to ensure that it is balanced. You check. So when grade 10 we discussed to say the number of atoms for that particular atom of an element on the left must be equal to the atoms on the what? On the right. So let's do a quick check. How many atoms of sodium are on the left hand side? On the right hand side? The chloride ions? On the right hand side? The silver ions? On the right hand side? Nitride ions? This side nitride ions? The oxide ions? This side? Thank you. So from that we can tell that the equation is what? Balanced. So from there, this 0.5 grams we've been given is for the impure sample. What we want to find is the percentage purity. So you don't, at first you don't work with this. So what you are supposed to do is to use this mass for the precipitate formed. So in this case, what is the precipitate formed? The precipitate formed is what? Is silver chloride. So this mass, what we are supposed to do is to convert the given mass for this silver chloride, which is a precipitate, into number of moles. So, the first thing that we are supposed to do when we start working out, if we are given mass, volume, or concentration, we have to convert the given volume, mass, or concentration into number of moles. So, we want to convert this mass, the 1.15 grams, for the precipitate, which is silver chloride, into number of moles. So we begin. So we know to say number of moles is given by which formula? Yes, Khalid?
Mass over mass.
So number of moles is equal to mass over molar mass. So the mass we've already been given for the precipitate. What is the mass for the precipitate? Yes, Jennifer.
1.1.
So the mass is 1.15 grams. We are dividing this by the molar mass of silver chloride. So our silver chloride is here. What is the molar mass for silver chloride? Yes, there.
143.5.
What? 143.5. So, since it is molar mass, when we started looking at mole concept, we did discuss that molar mass has got what? Units. So, it is 143.5 grams per mole. This gram and this gram cancels out. This pen and this over cancels out when this more comes on top. So it will just be more. So what is 1.15 divided by 143.5? Mukadipi?
8. multiplied by 10
to the exponent
10 power
negative 3. Moles. These are number of moles for what?
silver chloride.
For silver chloride. Now, let's round it off, this one off. So, we leave it to 2 decimal places. So, we say 8.01 to the exponent negative 3 moles of silver chloride. We've not been asked to find the number of moles. What we want is to find the mass of the pure sodium chloride which reacted with silver nitrate. So from there, after finding the number of moles for silver chloride, what are we supposed to do? Yes, Maxencio.
We will equate the number of moles of silver chloride to sodium chloride.
So he's saying we are going to equate the number of moles for sodium chloride to the number of moles of silver chloride. So from our balanced chemical equation, what is the mole ratio? Memory. So the mole ratio is 1 to 1. To those who don't know, the number of moles, the mole ratio, we are getting it from this balanced chemical equation. In front of sodium here, we've not written any number. That is the one we are writing in front there. And in front of this sodium, we've not written any number, meaning in front of this, there is 1. No wonder our mole ratio is 1 to 1. Now, on our next, we want to find the number of moles for this sodium. So, we represent it by what? By X. So, X number of moles for sodium chloride to how many number of moles for silver chloride? These number of moles we calculated up here, which is 8.01 by 10 to the exponent negative 3. So now, since our mole ratio is 1 to 1, even if we cross multiply, the value for X will be 8.01 to the exponent negative 3. We have to cross multiply there, although we don't show because it will be more like we are cancelling. Are we together? Yes. So, this means that when we cross multiply, the value of X will be equal to this same value because the mole ratio is 1 to 1. So, the number of moles will be 8.01 to the exponent negative 3 moles of sodium chloride. Are we together there? So now what we've found are number of moles for sodium chloride. So now we want to find the mass of sodium chloride. We want to find the mass of sodium chloride. But we know from our earlier equation to say number of moles is given by mass over molar mass. What do we want to find? We want to find what? The mass. So what do? We make, yes, simple. Come again? We make mass the subject of the formula. So what do? This is the same as over 1, not so?
Yes.
Then we cross multiply there. So it is giving us mass is equal to number of moles multiplied by what? Molar mass. Number negative 3 moles. We are multiplying this by the molar mass. What is the molar mass for sodium chloride? Dresden?
58.5 grams per mole.
It is 58.5 grams per mole. So now, what happens here is, this mole and this per mole, these will cancel out. Are we together?
Yes.
Mole and per mole cancels out. We are dealing with the gram, which is a unit of what? Mass. So from there, we multiply everything. We multiply 8.01 to the exponent negative 3 multiplied by 58.5 grams. What is it giving you? Maxenjo?
0.4680.
0.468 grams. So now we are advised to leave. We've written everything the way it is appearing on the calculator. On the next step, we round off. And we are advised in science to round off at least to 2 decimal places. So rounding off this value to 2 decimal places gives us what? Cheapo. 0.47 grams. So this is the 0.47 grams of what? The pure substance of what? Sodium chloride. Of pure sodium chloride. So this is the mass. Mind you, in our question, we were told that the mass of the pure substance together with the impure was amounting to 0.5. So now, for us to find the percentage purity, when we've reached this far, we now bring in our equation. So, we are going to say percentage purity, which is given by mass of the pure substance over mass of impure substance we multiply this by what? 100%. So now, we have calculated the mass of the pure substance. Not so?
Yes.
What is the mass of the pure substance? Yes, Jen?
0.47.
So the mass of the pure substance is 0.47 grams. We divide this by what? The mass. We are dividing this by what? Yes, John?
0.5.
We are dividing this by 0.5 grams. Then we multiply it by 100%. We are starting with division. When we divide 0.47 with the 0.5, what is it giving us? Florence? It is giving us 0.94. Mind you, this one has got no units. Then we multiply it by what? 100%. So what is 0.94 times 100%? Florence? 94% of sodium chloride. So the percentage purity is equal to 94% of what? Of sodium chloride. I know some people might be asking to say this 0.94 there, it has no units. It has no units there because the gram there and this gram and that gram, these two do what? They will cancel out time.
Yes.
Yes. So this was easy, the percentage purity for sodium chloride. So some people might be wondering, to to say what is the significance, what is the importance of us finding the percentage purity. Percentage purity is very important to those who are into mining. If you want to set up a mine, you can't just start mining. You get the ores of that particular metal you want to start mining, it undergoes percentage purity. If at all that the mining will be making profits for you. If the percentage purity is very low, it means you'll be running on a loss. Are we together?
Yes.
So this is the importance of percentage purity. And this is how we work out percentage purity that involves stoichiometry. Well, class, we've come to the end of this lesson. On behalf of the production group, I was the teacher, Poch Lamba. Until we meet next time, for now, bye.